What's the one thing that connects the tiny microchip in your phone to, say, the can of soda you might be drinking right now? The answer is probably not what you'd expect. It's water. But we're not talking about just any water. We're talking about water that's been purified to an almost impossible standard. So let's dive into the hidden science that really does power our modern world. It really sounds like the beginning of a riddle, doesn't it? What on earth could connect the super sterile world of electronics with your favorite fizzy drink? Well, like I said, the answer is that same unsung hero, unbelievably pure water. Let's break down exactly how. Okay, first, to really get this, we have to understand the problem. For a factory, regular tap water isn't just a resource, it's a huge risk. It's this invisible threat that can bring a multi-million-dollar operation to a grinding halt. See, untreated water is basically a silent saboteur inside a factory. You've got minerals that create scaling, which literally chokes the life out of pipes and boilers. Then you have corrosive elements that just eat away at incredibly expensive machinery. Any kind of contamination can ruin an entire batch of products. And of course, all of this leads to breakdowns and downtime, which costs a fortune. So, how do you fight back against a problem that's literally part of nature? Well, you do it with a brilliant piece of engineering that turns one of nature's own processes completely on its head. And this is where reverse osmosis, or RO, comes into the picture. Now, to get reverse osmosis, you first have to understand regular old osmosis. It's a fundamental process in nature. Just think of it like this. Water always wants to create balance, so it will naturally flow from a less salty or less concentrated area to a more concentrated area. It's just nature trying to even things out. No energy needed, it just happens. And here is where the reverse part comes in. Instead of just letting nature do its thing, engineers apply a ton of pressure. This force literally overwhelms that natural flow, and it pushes the pure water molecules backwards through the membrane, leaving all the nasty stuff, the salts, the minerals, the contaminants behind. And the membrane they use is just incredible. The pores in it are just 0.00001 microns wide. I mean, to put that in perspective, a single bacterium is about 1 micron wide. These pores are so ridiculously small that only pure H2O molecules have any chance of squeezing through. So how well does it actually work? Well, an industrial RO system is an absolute purification powerhouse. We're talking about stripping out up to 99% of all dissolved solids, 99% of bacteria and viruses, and even 99% of heavy metals. It is, without a doubt, the gold standard. Okay, so how does this all fit together into one big machine? Well, you can think of it as a journey the water takes through this high-tech gauntlet, where every single stage is designed to get it closer to ultimate purity. The whole process really has 4 key stages. First up is pretreatment. This gets rid of the big stuff like sand and chlorine that could wreck the delicate membranes. Second, a massive pump creates that high pressure we talked about, the force that makes it all happen. Third is the membrane separation itself. This is where the magic happens. The water is split into the good stuff, the pure water called permeate, and the wastewater full of contaminants called reject. And finally, there's a final polish, often with UV light, just to make absolutely sure the water is sterile before it goes anywhere. So, why does all of this matter so much? Because this ultra-pure water is the invisible ingredient that makes so much of our modern world actually work, in places you would just never, ever expect. And this is where it gets really fascinating. In the world of electronics, a single microscopic speck in the rinse water can destroy an entire microchip. For pharmaceuticals, this level of purity isn't just nice to have, it's a strict legal requirement. And get this, in the auto industry, that flawless spot-free paint job on a new car, that's only possible because the final rinse uses RO water. Without it, you'd get ugly mineral spots that would permanently ruin the finish. It's truly the hidden ingredient in everything. But the story doesn't end here. This technology isn't just sitting still. The future of reverse osmosis is all about becoming smarter, greener, and more efficient to meet the demands of our modern world. And from a business perspective, it's an incredibly smart investment. I mean, when you factor in all the money saved from preventing equipment breakdowns, using fewer harsh chemicals, and guaranteeing perfect product quality every time, most factories find the entire system pays for itself in just 6 to 12 months. After that, it's just pure savings. Plus, it's getting so much greener. These new low-energy membranes are a total game changer, cutting electricity use by as much as 30%. That makes the whole process not only cheaper, but also a lot more friendly to the environment. And the next wave is already hitting the shore: smart technology. The RO plants of the future are being built with AI and connected sensors. Just imagine a system that knows it needs maintenance before it breaks down. A system that automatically fine-tunes its energy use and runs 24/7 with zero human error. That's not sci-fi, that's where industrial water is heading right now. So all of this leaves us with a pretty big question. In a world that is constantly demanding more advanced products, higher efficiency, and greater sustainability, is this kind of high-tech purification the future for every single drop of water we use?